Dear Mr. Chairman, dear colleagues, please let me to give you today a talk about our typical field in which our department is doing investigations within decades. The field of organofluorine chemistry concerning fluoro-containing substituents, their introduction into organic molecules, investigation their specificity, and possibility to change some properties of the molecules. So today I would like to concentrate our talk on one substituent, tertiary perfluorobutyl group. Its introduction for the aromatics, a little bit about the history of this group, and about the interesting way how to do it. This group is rather rare in contrast to perfluorotertiary-butoxy-1. The last one you can find out in different works. But the limitation for the perfluorotertiary-butyl group is, of course, the method of the introduction. The construction of the corresponding perfluorinated anion, CF3 3 times, is based on the chemistry of perfluorobutene, which is isobutene, which is a very toxic molecule, the most toxic one among others in the field of fluoroolefins. That is why this chemistry is really limited to some works made in the last century, and in some of these works we really took part, as you can see on the slide 2. It's very interesting that this year not only our group was interested in the chemistry of the introduction of perfluorotertiary-butyl-1 into the organic molecules, but on this conference you will see also another report, but this report, if I'm not mistaken, is really concentrated on the reagent. And my talk I would like to make to show you the way to only one organic molecule with perfluorotertiary-butyl group, corresponding phenol. I think that this molecule will be very interesting one for the further research work in different fields. Okay, few words about our former results and our experience with perfluorotertiary-butyl group. In some works we really made efforts for the easy way to construct the perfluorotertiary-butanol, and you can see how it has been done on the base of the very available anhydride of trifluoroacetic acid. And some of our works were due to the chemistry of perfluorotertiary-butyl that is introduced to the nitrogen acid, and afterwards construction of the heterocycles in which near the nitrogen atom perfluorotertiary-butyl is attached, or let us say standing by. General idea of our work is really based on the para-quinone-metides chemistry. There are very interesting compounds with different substituents at the corresponding part of the molecule where instead of oxygen, second or one oxygen in quinones, their carbon-attached group are standing. But it's noteworthy to outline that corresponding molecule with two CF3 groups of one oxygen atom is changed to CF3 twice moiety, and you can find out information about this compound only in one publication by Professor Shepard, quite old one. Also, I would like to say that utilization of the CF3 introducing reagent as trimethyl CCF3 was really limited to 1,4-trifluoromethylations. And in our work, we were thinking, as you can see, looking to the paraquinone methyl with 2CF3 group, we are looking for the 1,6 introduction of such a group. So how to synthesize the starting molecule up to the Professor Shepard's work? Starting phenol, in which two neighboring 2,6 groups are quite big ones. They could be methyl or tertiary butyl group as well, was constructed by the introduction with hexafluoroacetone, the corresponding CCF3OH group, and then chlorination. That really is, after the action of the base, is giving us possibility to construct such a paraquinone monomethyl. This starting material in this molecule is not absolutely stable due to the fact that we can vary the substituents into 6 position to the oxygen. I would like to say that compounds with methyl are really unstable. They can live in the laboratory up to few hours, and with tertiary butyl group they are more stable, and these compounds it is easier to utilize. So we synthesize starting molecules, and you can see on the slide number 4, and it was very interesting for us its possibility to be attacked by carbon nucleophiles. You can see various nucleophiles which we added to paraquinone methyl molecule, and you can see that the addition products are formed very easily. In case, of course, when we use not only CH2 active molecules, but corresponding metal salt with sodium, for instance, and the yields are very good. So you can introduce the carbon moiety with the CO methyl, with cyana groups, and so on. Also, it's very interesting that all these compounds are rather stable, and immediately forms after the reaction the corresponding benzyl molecules. So that is really the way, after the introduction of carbon group to the corresponding CCF3, CF3 twice moiety, the corresponding benzyl molecules, so that what we are looking for. And when we came to the utilization of trimethyl CF3 silicon reagent in the presence of the F- catalyst, we have seen that when we used the catalytic quantity of the CF3 silane, then in this case mainly the attack have been to the oxygen part of the quinone. That is really understandable, but not very interesting for us. But in the case when we increased the quantity of the activation by fluoride, in this case as well, we have seen the formation of the attack of the carbon double bond with CCF3, with CF3 twice substituent, and 5% of the desired perfluoro tertiary butyl moiety have been achieved. And at least we understand that we need to block the oxygen part of the quinone to get the real result we are looking for. So we introduced the bulky substituents into sixth position, two tertiary butyl substituents, and in this case, upon attack of CF3- from the CF3 silicon reagent, we've got a very interesting set of the compounds after the reaction. You can see compound 11, that is the molecule we are looking for, then complete destroyness of the molecule and CF3 group instead of everything, compound 12, attack to the oxygen atom, and then you can see as well the phenolic molecule with 2,6 substituted tertiary butyl groups, but unfortunately that is only 7 fluorine molecules near the substituents, perfluoroisopropyl group fluoride instead of CF3- attack. But when we used not really the silan with activation, but before that organized so-called silicate, so that means that we took silane, then afterwards at a low temperature without addition of the reagent, we added only fluoride, and we have seen the fluoride dissolved, so that is formation of the corresponding silicate, and this reagent gave us possibility with 0 yield of compound 14, overall yield the same, a little bit even better, and then we have the mixture which we used for the gas chromatography and liquid chromatography to get the desired molecule which we are looking for. Afterwards, without any problems, as usually in organic chemistry, we can get rid of the tertiary butyl group in the molecule, and as a success, we obtained the phenol with perfluoro tertiary butyl group in the para position to hydroxy group. This molecule is highly volatile, and you know, like a crazy butterfly, you have to look after it, but it's absolutely a real molecule which can be stored for a month without the decomposition. So finally we really got the success, and I think that this molecule can be the parent for the construction of variety of aromatic compounds with perfluorotertiary butyl group, that's what we are doing in the moment, and as well, of course, for the utilization on different very interesting molecules with perfluorotertiary butyl group. As an example, as a possible application, I would like to draw your attention for such unknown compound, which is very interesting, and I think that people specialized in catalysis can be interested in such molecules as well. So that is the end of my presentation, and thank you very much for your kind attention.